So today we are going to be talking about projectiles, both horizontal and non-horizontal. Here is a really cool fact. If a gun were fired horizontally and at the same time a bullet is dropped and the bullet is exactly the same size, same model, everything, if it was dropped from the same height, they both would hit the ground at the same time. The question is why? We look at it and we know that the vertical motion can be viewed as a separate entity from the horizontal motion. Vertically, and that is in this direction here, both bullets have zero initial velocity. It's starting from rest and accelerates downwards at a 9.8 meters per second squared. The time to fall would be the same distance for either of these, so therefore they would be the same. Imagine that you were kicking a dog horizontally off the cliff. So horizontally, it would go this direction with an initial velocity of v sub h, and the h stands for horizontal. Assuming that there is no air resistance, so negligible just means very little, enough to just ignore, he falls in a path of a parabola. So notice that he kind of goes down in this curve, okay, until, of course, he splats. Why is this? Let's consider his motion to be the sum of his horizontal motion and his vertical motion. We can treat these separately. And notice here that v sub h is the horizontal velocity, and then v sub v is the vertical velocity. Sometimes you might also see vx and vy. Just be consistent. It doesn't really matter which subs that you use as long as it makes sense and you're consistent. For horizontal motion, assume that there's no air resistance. There are no horizontal forces working on this little dog over here. So this means that the dog moves with a constant speed, and its horizontal distance is, remember that speed or velocity equals distance over time. So we know that his or her traveled distance is the velocity times the time. And this is derived again from the velocity equals displacement over time for linear motion. So we're treating this as linear motion. Vertical motion. Assuming no air resistance exists, there is a constant force downwards, and we know that this is equivalent to mass times gravity, and this comes from F equals mass times acceleration. However, it is g because it is the acceleration due to gravity. So this means that the dog moves with a constant acceleration of 9.8 meters per second squared, and it is denoted by, and here it says y, traveling y because it is the y-axis of a graph. If you were to look at it in that aspect, it would be this equation here, which is one of our SUVAT equations. Now, parabolic motion, this is what's happening to the dog. Since we know, and this is because u, the initial velocity, is 0, we know that this is the new equation for y. We also know that the equation for x, so the horizontal motion, it is going to be velocity times time, and this is the distance or the displacement. If I were to substitute the time, so if I were to substitute x over v sub h into my first equation, then what we would have is this new equation, which you may recognize as the formula for a parabola. Another piece of ultra cool physics. So, remember how we discussed that there are 3 kinds of falling object questions that we can solve using SUVAT. This is the 3rd type of question. It's more difficult, but if you remember the rules, and they're really easy to solve. When solving for projectile motion, you want to draw a diagram, and here is where you can put 2 and 3 together. So steps 2 and 3, you can list what is known in the vertical direction or the y-axis, also sub v. Number 3, list what is known in the horizontal direction, x-axis, sub h. Highlight what you need, pick the equation, and solve. One thing to note is that the gravity is 9.81 meters per second squared in the vertical direction. For horizontal direction, however, gravity, the acceleration due to gravity, is 0 because there are no forces acting on it in the horizontal direction. Here is an example. A dog is kicked off the top of a cliff with an initial horizontal velocity of 5 meters per second. If the cliff is 30 meters high, how far from the cliff bottom will the dog hit the ground? What is his speed as he hits the ground? So this is going to take a little bit more work, so let's go ahead and begin. So first, obviously, draw a diagram, which I have already put over here on the left-hand side. Step 2 and 3, I'm going to put these two together, but you can do these separate. List the horizontal and vertical motion. Here's what I have. H is for the horizontal or the x-axis, and V is the vertical for the y-axis. Here are my variables. I have an initial velocity of 5 meters per second, and I know that in the horizontal direction, my acceleration due to gravity is 0. I don't know any of these other variables. In V, I have a displacement, or I'm 30 meters high. My initial velocity is 0 because I'm going to be just going straight down. The final velocity I do not know, and of course the acceleration due to gravity in the vertical direction is 9.81 meters per second squared. Time is unknown in both. The easiest one to solve for is time, so we're going to do that first. Solving for time, here's my data. I'm going to use the vertical data points, and I look over here and I say, okay, I have S, U, A, T. I need to find T. So I'm going to use this equation, plug everything in, and the dog hits the ground after 2.47 seconds. Awesome. Solving in the horizontal motion, I know these data points. Let's go ahead and choose. So now we're going to be choosing this one here because we're going to try to solve for S, which is the displacement. So here I have, after plugging everything in, rounding it off as 12.4 meters. So the dog hits the ground 12.4 meters from the base of the cliff. There we go. There's his parabola, and there's the dog. If I were to ask what is the dog's speed as he hits the ground, here is the data points that we have for the vertical. And we know that we need to choose something in order to find the speed, which is going to be this velocity here. And we're going to choose this one here because we have S, U, V, A. And we have T. Okay, so we've got everything. We have U, V, A, T. All right, when we plug everything in, we get an answer of 24.2 meters per second. For non-horizontal motion, where we know the angle that the object was launched, here's what we can do. So here's an example where a dog was fired out of a cannon at a 30-degree angle. The dog reaches the velocity of 25 meters per second at its highest point. Find the distance that the dog traveled and the maximum height the dog had in his journey. So down here, what you're going to notice is here is the trajectory of the dog being launched out of the cannon. What I've done is created a few vectors here to complete what it looks like a triangle. So what I want to do is split the initial velocity into vertical and horizontal components. Because we're given this angle, we should be able to find these sides using sine and cosine. So here's what I would do in order to find the initial velocity of the horizontal portion, which would be 25 cosine 30. And then the initial velocity of the vertical, which would be the 25 sine 30, which gives us this amount for our velocities. The next step that you're going to want to do is to look at the vertical motion. Here are all my data points. So I'm listing out all the SUVAT, all the variables that I have. So I want to solve for t. I'm going to use my acceleration. I'll use this initial velocity. And I will also use my displacement, which is 0. And that's based off of the fact that when the dog hits the ground again, the displacement will be 0. So let's go ahead and look at this, and I know that I'm going to be choosing the fourth equation. And when I plug everything in, I should have a travel time of 2.63. So that's for so right here is half of that time. So this would be half of 2.63 seconds. And then the next portion of the travel would be the total time of 2.63 seconds. So it took 2.63 seconds to travel the entire distance, which we need to find out next. Looking at the horizontal motion, where we know that the entire trip took 2.63 seconds, we also understand that horizontal speed means it is in a linear fashion. So we're looking at it as if he is just traveling in this straight line. So what we know is that speed or velocity equals distance over time. So solving for distance will give us this information right here, the range of how far the dog traveled. So the distance traveled is 21.65 meters per second, and that is taken from the initial velocity of the horizontal motion, and then we multiply that by time, and that would give us a total of 56.9395 meters, or 57 meters. Looking at our data points, we need to try to find what the displacement is here, the height, right in the center. Now remember earlier this was 0 because throughout the entire 2.63 seconds, the displacement would be 0. But because I want to know what the highest point, which would be in the middle, we don't know that, so there's a question mark there. The 2.63 seconds is again for the entire trip, so we're going to also have to half that in order to put it right in the center with this. So we need to find an equation that we can use in order to solve for s, given that we have all these other variables. So let's take a look at these equations and let's see which one we should choose. Okay, so this one is going to allow us to solve for s, while we do have the information for u, v, and t. Plugging all this information in, and notice that my seconds is halved because I am in the middle of my trip, or the dog is in his middle of his trip. So when you solve for that, you will get a total of 8.2 meters for the height of the trajectory. And pretty much that's it, so just be prepared to use this in class.